I'd like to talk about vertical asymptotes. Now, this very first graph that you can look at here is 1 divided by x. Okay, 1 divided by x. And I've graphed this over here, and you can see that we've got this kind of weird spike in our graph occurring at 0. And the reason it's occurring at 0 is because we all know you can't divide by 0. So I can't evaluate this function at x equals 0, so you kind of have this just break in the graph. Now, the reason it looks the way it does is because of what happens when you divide by extremely small numbers. So let's look at the positive side first. Imagine if you were, plugging in 0.5. Well, 1 divided by 0.5 is 2. So, okay, there's 2. Now imagine you were plugging in 0.1. 1 divided by 0.1 is 10. It's way up here. If you plugged in 1 over 100 or 1/100th, you'd get 100. If you plugged in 1 over 1,000, 1 divided by 1,000th is 1,000. So as you plug in numbers ever getting closer to 0, you end up getting larger and larger outputs. And likewise, if you plug in numbers that are extremely close to 0 but coming at 0 from the negative side, you end up with extremely large negative values. And that's what causes this kind of break in my graph. Now, let's look at a different one. So here I've got 1 over x minus 4. And again, you should think to yourself, well, I can't divide by 0, so I cannot evaluate this function at 4, because 4 minus 4 would be 0. And again, you can see that same thing happening at x equals 4, where we've got this break in our graph. Now, the last one I wanted to look at was this. I have x minus 4 over x plus 4 times x minus 4. Now, just looking at this, I think you'd say, well, I can't evaluate the function at negative 4 because that would be, 0 times negative 8, but that would be 0. I also can't evaluate the function at 4 because 4 minus 4 is 0, and this part would be 8, but 8 times 0 is 0. So I would expect to see 2 of these asymptotes. I'd expect to see one at both negative 4 and positive 4. Let's take a look. And you can see that, in fact, I do see an asymptote here at negative 4. You can see negative 5 there, negative 4. But over here at positive 4, I don't see anything. The reason for that is we have a factor in common that could divide out and simplify to 1 over x plus 4. And the asymptote then is only at negative 4, the thing that would make the simplified version 0. Now, we've learned that positive 4 is what's called a discontinuity. There is something going on at 4. I can't plug 4 into my equation because I'd be dividing by 0, but I don't end up with an asymptote. So this is why we need to be so careful when we are simplifying our rational functions. Because if I just said, where is there a discontinuity in this original graph, the discontinuity, the problem, is at both negative 4 and positive 4. But if I said, where is there a vertical asymptote, it's only at negative 4. So it's only at the spot that would make the denominator 0 after I have done my simplification. I would recommend, as you start doing vertical asymptotes, that you graph these either on a graphing calculator or with Desmos, so you can get a sense of what they look like and where they are. And to be honest, there will be times where we do have 2 asymptotes. Let's change this one just slightly so it doesn't have any simplifying that can be done. So if on top I made it an x minus 3, see, now it doesn't have any simplifying that could be done. So now it does end up with 2 asymptotes, negative 4 and positive 4, because there's no reducing to get rid of one of those kind of problem areas in the denominator. So it's always important to simplify and then kind of reanalyze your function, especially the denominator, after you've simplified. If this video helped you, please like and subscribe for more math help.